I would like to show you a few ways to work this problem. One of them is with the binomial table, and then one on the calculator. When we first read the problem, it's helpful to recognize that we are looking at a binomial distribution because these multiple choice questions are either right or wrong. So there are 6 questions, they're multiple choice. Each question has 4 answers, one of which is correct. So the sample size, or the number of repetitions of this quiz, is 6 questions. Each question has 4 answers and 1 is correct. The probability of success, randomly guessing, is 1 in 4, or 0.25. Richard doesn't know, he didn't attend class, so he's just randomly guessing on all 6 questions. That means it's a binomial distribution, probability of success 0.25, sample size is 6, or the number of repetitions is 6. The probability that he answers all the questions correctly is the probability that the binomial random variable x equals 6. 6 of them are correct. To do this from the table, we can read the binomial distribution table. When I click on that here from MindTap, it initially showed pretty small. So here's my 100% and difficult to read, but as I click in or use Control plus, I can zoom in and read the numbers. So now we need to locate ourselves on the table. Probability of R successes in N independent trials with a probability of success P. So probability of success P is 0.25 for this quiz. The number of repetitions, N, is 6. And we would like to know the probability that he gets all 6 correct. So we're down here, 6 repetitions, all 6 correct, probability of success 0.25. Shows that the probability of him getting them all correct by guessing is 0%. Not too good. The way that we answer this question in the calculator is to use the binomial distribution. The binomial distribution, and we need PDF, probability distribution function. The input for the binomial PDF is N, P, and X or R from your book. So this happens for us. Let me bring my calculator over here. In the distribution menu, second variables opens the distribution menu, second key, then the vars key to access distributions, and we would like to scroll down to the binomial PDF. Now, depending on what calculator you have, that will change where exactly the binomial PDF is, but he's down here somewhere. There it is for me in part A. Yours might be 0 or B. The trials are 6. Probability of success 0.25. The X value is all 6. Paste those in. If you don't have the template that asks you for the trials, the probability of success, and the X, you'll just enter them here with a comma left of the parentheses and press enter. This number I got was 2.4 e to the minus 4. That's a fancy calculator way to talk about scientific notation, which means we move the decimal place 4 places to the left. 1, 2, 3, 4, giving us a probability of 0.123024. So the reason that the table said 0 is because it only had 3 decimal places, 2 was small, so it rounded just to 0. It asked for 3 decimal places, we do the same. The probability that he answers all the questions incorrectly is the probability that the number of correct questions, the binomial random variable x, equals 0. From the table, our number of trials is still 6. Now the number of successes r or x is 0, and the probability of success is 0.25. That's 1.78. In the calculator, same plan, second variables for the distribution menu, scroll down to binomial PDF, we want exactly equal to 0 successes, trials are 6, successes 0.25, probability of success 0.25, 0 successes is 0.178. Also in the calculator. So I suppose I should write that. Calculator. Binom. PDF. 6 trials. 0.25% chance of guessing correctly. 0 correct. Gave 0.178. Same answer. Now, the probability that he answers at least 1. These questions are tricky. At least 1. First, we'll use the rule for mutually exclusive events and the probability shown in the table. So what that means is the probability of at least 1 correct is the probability that he gets 1 correct, plus the probability there are 2 correct, plus the probability of getting 3 correct, plus the probability of 4 correct, plus the probability of 5, and lastly the probability of all 6. That's what's meant by the probability of at least 1 being correct. Now we can read these values right from the table. I don't want that. So I'm going to line this up. We have 0.25 as our probability of success. So I'm looking at this column. Probability of 1 success is 0.356 plus the probability of 2 successes. One success, 0.25, 0.356, 0.297, 0.132. Probability x equals to 4 is 0.033. X equal to 5, 0.004, and the probability of 6 is 0. So we can add all these guys up and put that solution right there. That's a lot of work though. We had to add 6 numbers together. Using the fact that the probability of r is greater than or equal to 1 is 1 minus the probability that r was 0. So at least 1. Notice the only guy that's missing from here, the only guy we didn't add up, was 0. So we can use the complement rule to say we have the probability of them all happening is 1, 0 or 1 or 2 or 3 or all the way up to 6 questions correctly, minus this probability that he got them all wrong, which we said was 0.178. To get the probability that at least 1 is correct. Now that's a little faster, less chance for error, just 1 minus 0.178 is 0.822. Now sometimes the rounding with MindTap can be tricky, so you might want to subtract the whole decimal place we found from before. So by using this up key, I can go back and grab this 0.1779785, get that whole decimal place and press enter. Then I'm subtracting the whole thing. Or we can do 1 minus and re-enter the function, the distribution menu binomial PDF. and px. And now it's 1 minus that PDF 0.822. Now in this case it didn't change whether we use the rounding number to subtract or not. But you might want to be wary that if you use a rounded number and you get it wrong, try again the non-rounded. Of course this is more accurate and that's preferred, but I understand that it can become cumbersome. Now the third way we can do these is by using the actual formula for binomial probabilities. It just gets way more cumbersome. The probability that x equals x is n choose x times p to the x times q to the n minus x. That's 3 things we have to compute, multiply together, and then in this part C, add together, which is why the tables are handy, or even better, the built-in calculator function, which will calculate this for us, is preferred. I don't mind which method you use. If you want to bring the tables to the test, do that. If you like to use the calculator or the formula, go for that. If you like to use the calculator, use that.